All right, so far with systems of equations, you have learned how to solve with graphing, you have learned how to solve using substitution, and you have learned how to solve using elimination. And every single time we've done this up until this point, there has been one solution where the two lines intersect at one point, or when you eliminate, you get 1 point of an answer like 2, 3, or -4, 1. The point of intersection, there's been one solution, okay? What we're going to talk about now are lines that have no solution or infinitely many solutions. So what I've highlighted in yellow, this is the new stuff for this section number 4. So you can still solve any way you choose. You can solve with graphing, with elimination, or with substitution. But when they have no solution, they're never going to intersect. And when they have one solution, they intersect at infinitely many points because this is really two lines that are on top of each other, and they look the same. So this first one, let's practice using our graphing method. I'm going to try to blow this up a little bit. There we go. So we're going to solve a system by graphing and by substitution. So I'm going to graph first 3x plus 1, plot my b, rise and run. Now on this first line, I'm going to plot all possible points, both forward and backward, okay? Because this could be, oh, what'd I do? But this solution could intersect at any of these points on the graph. So I got to make sure that I go both forward and backwards to graph the line. And then the second line is 3x minus 3, so my y-intercept is -3, up 3 over 1, up 3 over 1, up 3 over 1. Uh-oh. What's happening? They are never going to intersect. These are parallel lines, okay? Parallel lines have the same slopes and are therefore never going to intersect. Okay, so this answer is no solution. Now, if I were to solve this by substitution, I would plug in 3x plus 1 for y, so it would be 3x plus 1 equals 3x minus 3. When I move my lesser variable, the variables both cancel out, and I'm left with 1 equals -3. Oh, goodness. And since that is not a true statement, 1 does not equal -3, this is no solution, okay? So no matter which way you solve it, you will get no solution. And these next 3 problems, I think, are supposed to be on your own, even though it doesn't say it. Possibly? No, none of them say on your own. Okay, I'll do a couple with you, and then you need to do some on your own. So this first one, we're going to graph. I know we're going to graph because these are both in y equals mx plus b form. Okay, so -x plus 3. And it has a negative slope, so it's going to look like this. I'm going to make all possible points. And then draw my straight line. And then -x plus 5, same thing over here. Once again, these have the same slope, but different y-intercepts. And they are never going to cross, so this one is no solution. This second one, I have y already by itself, so this one is perfectly set up to substitute. So I'm going to plug that in right there. So I'm left with 5x minus 5x minus 2 equals 0. So I substituted this part in for y and rewrote my equation. When I combine like terms, 5x minus 5x is 0. And I'm left with -2 equals 0. Since -2 indeed does not equal 0, this is also no solution. Okay, for this last one, this is also set up to substitute since one variable is by itself. So I circled what x is equal to. X is equal to 2y plus 10. Go ahead and plug that in for x. And I want you to solve this one on your own once you finish watching this video. So come back to this one. put a star by it. All right, next page. This problem is absolutely set up to eliminate because it looks like standard form of ax plus by equals c. So go ahead and look for the one you could eliminate. I see a plus y and a minus y. Those cancel out, and you add up the rest. So x plus x is 2x, and 3 plus negative 3 is 0. Divide by 2, 0 divided by 2 is 0. Well, looky there, this one's going to have a solution, which is totally okay. So if x is 0, you do the same thing we did with elimination and pick an equation to plug it back into. So x plus y equals 3. So 0 plus y equals 3, which means y equals 3, and your solution is 0, 3. So this one has one solution. This one is set up to substitute as well, so we're going to plug that in for y. So this is 4x plus 2, parenthesis, plug in my y, equals 0. Then we need to distribute this 2, so I have 4x. This should be minus, because 2 times negative 2 is negative 4x, plus 10 equals 0. 4 minus 4x, when I combine like terms, is 0. That goes away. And I'm left with 10 equals 0. Since 10 does not equal 0, this would be no solution. And the last one is set up to eliminate. And when I add these two systems together, I notice the x's eliminate and nothing's left. The y's eliminate. I have a plus 24y and a minus 24y. So that eliminates as well. So I have 0 plus 0. And I have negative 60 plus positive 60 also equals 0. So I am left with, at the end, 0 equals 0. And since this is a true statement, and 0 does in fact equal 0, the answer to this is infinitely, ooh, I can't spell, I-N-I-F-I-E-E-L-Y, many solutions. Okay, keep scrolling down. And the last question says the perimeter of the rectangle is 36 units and the perimeter of the triangle is 108 units. Write a system of linear equations to find the values of x and y. So remember, when we write a system, we are writing two equations. So the perimeter of the rectangle is 36 and the perimeter of the triangle is 108. So I have 6x and 6x, that's 12x, plus 24y is equal to 108. 6x and 6x is the 12x. 24y is 24y equals 108. Now be careful over here. It's talking about perimeter, but it didn't give us all the points or all the sides. So we have to do the rest of them. 2x and 2x is 4x. 4y and 4y is 8y. Perimeter is 36. Now this one is set up to eliminate, but nothing looks like it's eliminating right away. So we need to multiply this top system, and I'm going to choose negative 3 to get my x's to eliminate. So that becomes negative 12x minus 24y, and 36 times negative 3 is negative 108. And as you can see, if you add these two systems together, absolutely everything eliminates again. And 0 equals 0, which means this problem has infinitely many solutions. What that means is any value for x and any value for y, if you use the same, will work on both of these problems. So there are infinitely many solutions that will work to solve this problem. And that is it for section 5.4.